a few more examples to finish this lesson out. It's nice to see a range of things. Again, we're being asked to solve the entire triangle. So that means in this case, I have a missing side and missing angles. So given an angle and its including sides, okay? Remember when we did side, angle, side angle for triangle congruence? We talked about the sides and the included angle. That's a key starting point for the law of cosines. I have an angle and I have the two sides that make the angle. So I can set up my law of cosines, my first place to start, with s and the cosine of 85. So I'm going to go ahead and say that s squared is equal to 7.5 squared plus 5 squared minus 2 times 5 times 7.5 times the cosine of 85. Now it becomes just a crank the math out, being very careful about your order of operations. I can go ahead and add those first two. I can do this multiplication here with the cosine of 85. Go to your calculator, and you're going to find that s squared is equal to 81.25 minus 6.54 is what that turns out to be, cosine 85 times 75. Continue subtracting. S squared is equal to 74.7. There's no way that's going to be a nice, neat, exact answer if we take the square root, so we don't even bother. We go to our calculators and we say that S is 8.6. Once we have that 8.6 value, now we can flip over to the law of sines. Doesn't matter necessarily which angle you do next, I or U, for my own particular choice. Let's go ahead and do U next. So I'm going to set up that the sine of U over 7.5 is equal to the sine of 85 over 8.6. Cross multiply. 8.6 sine of U is equal to 7.5 sine of 85. Divide both sides by 8.6 to isolate your unknown value. Go to your calculator. Be very careful to get sine 85 equal times 7.5 equal divided by 8.6. I really think that's the safest way to go. You should end up with the sine of U being equal to 0.87, and that, use the inverse, U is 60.3. Once you have two angles, obviously our third angle is the easiest to solve for. Angle I is equal to 180 minus 85 minus 60.3, and that makes angle I equal to 34.7. Last few examples. Triangle ABC has angle A being 32 degrees, angle B being 81.8, and side A equaling 42.9. What's the measure of side C? First thing you have to do is draw a picture. And initially, you might not think you have enough information to draw your picture. But remember, sides are named lowercase opposite their angles. So side A is opposite little a, and side C is opposite little c. So if big A is 32 and B is 81.8, I know that side A is right here at 42.9. And they want to know the measure of side C. Well, initially you might think you don't have enough information. I can't really set up law of sines. I don't know angle C. But remember, you can always find that missing third angle by subtracting from 180. That's the most forgotten part. The easiest thing of triangles is that if you know two angles, you can always find the third. So this means that angle C is actually 66.2. Now, I know a pair of angles and their sides directly opposite each other. This is a great candidate for the law of sines. And so I'm going to say the sine of 66.2 over the side I don't know is equal to the sine of 32 over its side that I'm given. Again, I use as much given information as I can. Cross multiply 42.9 sine of 66.2 is equal to C sine 32. Divide both sides by the sine of 32. So I have 42.9 sine 66.2 all over the sine of 32 is equal to C. Now some of you might be wondering why I don't change the sine of 66.2 into a decimal right now. Why don't I change the sine of 32 into a decimal? Remember, the more times you round, the more rounding error you get in your problem. So I tend to wait until the very end so that I can multiply these two together and then divide by the other, carry all the decimals in my calculator, and I come up with a better, more exact answer. And you should find when you do that, that C is 74.1. Now, what fun would it be without a word problem or two? So, an observer is near a river and wants to calculate the distance across the river. He measures the angle between his observations of 2 points on the shore, one on his side and one on the other side, to be 28 degrees. The distance between him and the point on his side of the river can be measured and is 300 feet. The angle formed by him, the point on his side of the river, and the point directly on the opposite side of the river is 128 degrees. What is the distance across the river? Now, first of all, we have to figure out where the R goes. And your key thing that helped me figure it out is the distance between him and the point on his side of the river can be measured and is 300 feet. So here's our observer. This is the same side of the river. He measured this point and this point being opposite, and that makes this the river. And that was at 28 degrees. So we're going to go ahead looking at what we are given here. I am given a side opposite and an angle that match up, and I'm given a side opposite and an angle that matches up. And so if I think about it, my best candidate here for finding R is the law of sines. And I'm going to talk about the sine of 28 over my unknown is equal to the sine of 24 over 300. If I cross multiply, I end up with 300 sine 28 equal to R sine 24. Divide both sides by the sine of 24. I have 300 sine 28 divided by the sine of 24. That equals R. Quick trip to your calculator. And we are going to talk about sine 28, enter, times 300, enter, divided by sine 24, enter, 346.3. R is 300, did I say 46? 346.3 feet. And now our last example. To approximate the length of a lake, a surveyor starts at one end of the lake and walks 240 yards. He then turns 110 degrees, So if you can imagine your little guy right here, and he's going to turn and walks 270 yards until he arrives at the other end of the lake. Approximately how long is the lake? Now his angle that he turned is 110. So that means the angle between the 2 points that we are trying to measure is actually 70. Remember, 180 makes a straight line. The last two examples are great examples of how real life surveying and landscaping stuff, measurements, wildlife biology, geosurveying, all of that is going to use trig and these cosines and laws of cosines. Very, very practical part of mathematics. So if I want to know little x here, how far is it across the lake? What is the information I'm given? Well, I'm given a side, an angle, and a side. And those happen to be the two sides that make the angle. This is opposite the angle, no. I know this is a great candidate for law of cosines. Actually, the only way to do this one if I want x. So x squared is equal to 270 squared plus 245 squared minus 2 times 270 times 245 times the cosine of 70. Now it's just calculator work, cranking it out. X squared is equal to 1,32925 minus 132. I got this 132,000 from squaring and then adding. Now I'm going to multiply the 132,300 times the cosine of 70, and that gives me 45,249.3. One more subtraction gives me 8,767 87,675.7. Square root that, and x is 296.1 feet. Yards. Check my label, yards. Be patient, keep your formulas handy, and plug it in and see where you get.